Hello guys, welcome to my YouTube channel or David Structure Hub. This is a place where you learn, build and innovate. So today I want to tackle problem number 3 under 3-moment equation, and I will be solving a question from past paper. This is Kenya National Examination Council 2009, and the question reads: Figure 3 shows a beam ABCDE built in at A and is supported on rollers at B, C, and D, with DE being overhung. The value of moment of inertia of the section over each of these lengths are 3I, 2I, and I respectively. The loading being as shown. Analyze the beam using 3-moment theorem and hence draw the bending moment diagram indicating the critical values. So the question carries 20 marks. As you can see on the board, we have the beam. So this is the beam. This is the beam. It is fixed at A, and the beam is overhanging at DE. So this is the loading: 100 kilonewton, a point load, a UDL of 5 kilonewton, and a point load of 40 kilonewton. Again, a point load of 30 kilonewton. We have 3I, 2I, I, and I. So meaning the I is varying. So solution, let's see how we can handle such a question. So when given such a question, remember where our beam is fixed, we will assume an imaginary span. So the first thing to do is to assume the imaginary span. So where the beam is fixed. So let's say, oh, that is an imaginary span. After doing so, create a space that will enable you to draw the shear force and bending moment diagrams. And as always, remember to do it on one page and not separate pages. Yes, like that. After doing so, now you can start solving the equation. So solution, we will begin by calculating free span moment. So span AB. Span AB, our formula will be W AB over L. So this one will be 100 times A, which is 3, times B, 7, minus 3 is 4, over L. L is 7. So this one is equal to 171.43. So that is our free span moment at AB. And then we proceed to BC. So span BC squared over 8. So this one will be 45 times L. L is 5 over 8. So this one will give you 140.63. 140.63 kilonewton meter. And then we will proceed to CD, span CD. Span CD, again, our formula will be WAB over L. So this one will be 40 times 1.5. So this is 1.5. And then the remaining one is 4 minus 1.5, which is 2.5 times 2.5 over L is 4. So our answer will be 37.5 kilonewton meter. After that, we will proceed to span DE. Span DE, our formula is minus WL. So this one will be minus 30 times L, which is 1.5. So this one will give you minus 45 kilonewton meter, like that. So after doing so, we will proceed and draw our diagram for free span moment. So let's draw it here. So that is our baseline. And then at AB, we have 171. So this is the maximum. $171.43, like that. And then at BC, we have 140 BC. So this one will be a parabola. So 140.63, like that. And then we have span CD. So span CD, we have at 7.5. Again, we approximate at 7.5. At 7.5. And then the last one is 45 at DE. So this one is 45. Like that. After doing so, our next thing is to apply three-moment theorem formula. And because we have a varying I or EI, we will use our second formula of three-moment theorem. So apply three-moment theorem. So for you to apply three-moment theorem, you need to consider two consecutive span. So we will begin from O as our imaginary span. So we will consider OA and AB. So span OA and AB. Having done so, we will write our formula based on this span we have chosen. So our formula will be MO LO IO plus 2 MA into bracket LO IO plus L1 I1 close the bracket plus MB L2 I2 is equal to minus 6 into bracket A0 X bar 0 L0 I0 plus A1 X bar 1 L1 I1. So why are we using LOIO A0 X bar 0? It is because this span OA, it has no loadings because it is an assumed or an imaginary span. That's all. Let's proceed. After that, now we will start by calculating our area and its centroid of our geometric figure as a result of maximum bending moment. So A1 X bar 1. So this one will be the area of this one and its centroid, or the area multiplied by its centroid. So the area is a half base times height, so it's 0.5 times 7 times 171.43 times the centroid. The centroid, you can use this formula B plus L over 3. So 0.5 times 7 times 171.43 times our A is this section which is so close to our common joint A. So, and our B is this one. So this is A, this is B. So A is equal to 3 meters and the B is equal to 4 meters. So this is 4 meters. 7 minus 3 will give you 4 meters. So this one will be 4 plus L, which is 7 over 3, like that. So our final answer will be our final answer will be 2200.02. So 2200.02. That is our A1 X bar 1. So it's 2200.02. A1 X bar 1. 2200.02. And then after that, now we can insert known values into the formula. So this is our formula. Our formula is MOLO, this one. So you can say, but MO is equal to LO is equal to IO is equal to, but MO is equal to LO is equal to IO is equal to X bar 0 is equal to 0, because that is an imaginary span. So we can insert our values, our known values into this formula. So we know MO, LO, IO is 0. So this one will be 0. And then 2 we'll have 2, this 2MA into bracket. This LO, IO is 0. So we will have L1, I1, which is L1 is 7 over 3 MA plus L2, I2, that is 7 over 3, and B should be equal to, this part will be 0 because 0 x 0 is 0. So we have negative 6, negative 6 negative 6 into bracket A1 x1 is 22, 0.02. Then you divide L1 I1, which is 7 times 3, like that. So we will have 14 over 3 MA plus 7 over 3 MB is equal to negative 628.58. Negative 628.58. So this is equation 1. Call it equation 1. So equation 1. We will proceed to the next span. So we considered span OAAB. Now the next span will be span AB BC. So span AB BC. Remember to consider two consecutive span. So let's now write the formula for this span. So we will have MA L1 I1 plus 2 MB L1 I1 plus L2 I2 plus MC L2 I2 is equal to negative 6 A1 X bar 1 L1 I1 plus A2 x bar 2 L2 I2. That is our three-moment formula for span AB and BC. So after that, we will start by calculating A1 x bar 1. So A1, it is now the area of this geometric figure as a result of the maximum bending moment for the span and its centroid. So the area will be a half times base times height. So it is 0.5 times height, 171.43 times base, 7. And then the centroid. Again, you can use this formula B plus L over 3. So now our A will change. This one will be our A, and this one B, because our common joint is B. A common joint is a common that is sharing or that is bordering two span, like B, you can see. So the section that is so close to A, to the common joint is A, and then the remaining one is B. So this one will be 0.5 times 171.43 times 7 times B, which is 3, plus L7 over 3. So our final answer will be 2000.02, like that. And then after doing so, we will go ahead and calculate A2 x bar 2. So A2 x bar 2. So A2 x bar 2 will be the area times the centroid of this parabola. So the area of a parabola is 2 over 3 times base times height. So the base is 5 and the height is 140.63 times the centroid is length. Its length you divide by 2, or a base over 2. So this is 5 over 2. So our final answer will be 1171.92, like that. So after doing so, again we will insert the known values into this formula. So L1 I1 is 7 over 3 MA plus 2 into bracket L1 I1, that is 7 over 3, plus L2 I2, this is 5 and 2I. So it's 5 over 2 plus MC, no, MB, plus L2 I2 is 5 over 2 MC should be equal to minus 6 into bracket A1 x bar 1 is this one. So it's 2 is 2000.02 over 7 times 3 plus 1171.92 over 5. 5 times 2. Yes, like that. You can simplify. You can simplify this one. So we will have 7 over 3 MA plus, you simplify this one using a calculator. So that is 29 over 3. 29 over 3 MB plus 5 over 2 MC is equal to negative 12 cents, negative 1274.59. So that is equation number 2. We call it equation number 2. Equation 2. Like that. Then we proceed. We consider another span. So our next span will be span BCCD. So span BCCD like that. So you can generate our 3-moment equation based on this span. So let's say MB MBL2 I2 plus 2 MC into bracket L2 I2 plus L3 I3 plus MB L3 I3 should be equal to minus 6 A2 X bar 2 L2 I2 plus A3 X bar 3 L3 I3 like that. So after doing so, now you can start again by calculating the values of area times its centroid. So we have a 2 x bar 2, a 2 x bar 2. So this one will be the area of this times its centroid. The area of a parabola is 2 over 3 times base, which is 5, times height 140.63. The centroid, it acts at the center of the base. So 5 over 2, or the center of the length. So that one will give you 1171. 1171.92. And then we move to a 3 x bar 3. So this one will be the area of this times its centroid. The area is a half base times height, so the area is 0.5 times height is 37.5 times base 4 times the centroid. You can use this one, b plus L over 3. So our A will be this one, then this one will be B, because a common jet is C. So 0.5 times 37.5 times 4 times B, which is 2.5 plus 4 over 3. It is 2.5 because 4 minus 1.5, so 2.5 meters. So like that. So our final answer will be 162.5. So that is our 3x bar 3. Then after doing so, we will insert known values into our formula. So we have L2 I2, which is 5. It's 5 over 2 MB plus 2 MC into bracket 5 over 2 plus L3 is 4 over 1. So the I is 1. We have only one I. Plus MD L3 I3. So it's 4 over 1 MD. And this one should be equal to minus 6 into bracket A1 A2 x bar 2 is 1171.92 over 5 times 2 plus 162.5 over 4 times 1, like that. And then we will get, or we will simplify our expression. So like that. So but we know, but MB is equals to negative 45. Remember, we calculated MB and we found MB to be 45 kilonewton meter. So it means where we have MD, we will multiply by negative 45 formula. So let's simplify. 5 over 2 MB plus 2 MC, 5 over 2 plus 4. So you can punch this in your calculator, 5 over 2 plus 4. Then you multiply by 2. You will get 13 MC plus into bracket minus 45 times 4. like that is equal to minus 6 into bracket our, no, you can just punch this in your calculator and get our final answer. So it's equal to negative 946, negative 946.9, like that. So we will have 5 over 2 MB plus 13 MC minus, now you can open the bracket, minus 45 times 4, and that one is negative 180. Negative 180 is equal to negative 946.9. So this negative 180 will cross to the other side. It will change negative to positive. So we will have 5 over 2 MB plus 13 MC should give you negative 946.9 plus 180. So our final expression will be 5 over 2 MB plus 13 MC is equal to negative 766, negative 766.9. So this is equation 3. So we call it equation 3. So equation 3. And this is our final equation. So after doing so, we'll arrange our equations in order. From equation 1, you come to equation 3, you come to equation 1, equation 2, and then the final one, equation 3. And then you will use your calculator to solve that equation. I don't use the long method because it will waste your time. So just punch it direct in your calculator. Someone may be asking, why did we not continue with span CD and DE? This is because DE is not a span. When DE is not a span, so we consider it as a span only when calculating our free span moment. But for 3-moment theorem, we don't consider it as a span. It's an overhang. So for 3-moment theorem, we only consider span which has 2 supports. So as you can see, this one, it only have 1 support, which is D. Then E is a loading, so on top of the beam. So that one automatically is not a span. So let us arrange our 3 equations in order. So our first equation was 14 over 3 MA plus 7 over 3 MB plus 0 MC. Remember, in our first equation, there was no MC. So we just we introduce 0 to make it 3 unknown. So 0 MC is equal to minus 6, 28.9 5/8. So that was our first equation. Our second equation was 7/3 MA plus 29/3 MB plus 5/2 MC is equal to negative 12. 74.59. So this was our second equation. So we had three unknown, MA, MB, and C. So that one is complete. And then the last one is 5/2 MB. So we don't have MA. So we will introduce 0 MA to make it three unknown plus 5/2 MB plus 13 MC is equal to negative 766.9. So like that, after doing so, you can easily feed or fed these values in your calculator and it will solve for you and give you the three unknowns. So this one implies MA is equal to MB is equal to MC is equal to. So MA is equal to negative 84.02 kilonewton meter. Then MB 101.36 kilonewton meter. Then MC negative 39. This is negative 0.5 kilonewton meter. So now we have now calculated our moment at respective supports. So moment at A is 84.02 kilonewton meter. Moment at B is 101.36, negative 101.36 kilonewton meter. And then moment at C is negative 39.5 kilonewton meter. So our next is to now determine our reactions. Our reaction, then we draw shear force diagram. So let's see how we can calculate our reactions. So let me create space for reaction. Now, for you to calculate reaction, you will split the whole of this continuous beam into a simply supported beam or a section like this. So we have A. So that is our A. And then you have B. So B, it is a common joint, so we will split. So this is RA as a result of A, and this is R, B1, R, B2. Like that. We'll proceed to C. Again, C, we have a common joint. So we have R C1, R C2. We'll proceed to D. So D, it will remain like that because It is not a common joint, so we'll have RD. And then we have a loading on top of it of 30 kilonewton. So here we have 30 kilonewton. And then we have here 40 kilonewton. We have a UDL of 45 kilonewton per meter. We have another one here of 100 kilonewton. So like that. So this is 3 meters. This is 4 meters. So this is 5 meters. We have 1.5. 1.5 meters. Like that. Again, we have moments. We have moments. We have moments. Like that. So at A, we have negative 84. At A, we have 84. .02. And then at B we have 101.36. And then at C, at 9.5. And then at D, we have 45. Remember our D, our previous D, we had 45. So like that. So now you can start calculating our reactions. So summation of moment at RA. Let's use the three static equation of equilibrium. So summation, we begin with this section. Summation of moment at RA is equal to 0. So it means we'll have RB1 going in anti-clockwise direction, and the distance is 3 plus 4. So this is minus 7. RB1. Then you come to this moment, in which direction? Anti. Minus 84.02 is already a moment. There is no need to multiply by a distance. And then you come to this loading 100 kilonewton in each direction, that is clockwise, plus 100 times 3. And then you come to this moment. It is going in clockwise direction, so plus 101.36. This one should be equal to 0. So which imply RB1 is equal to, so you can find your calculator and find RB1. But here I will just give you the figure for RB1. So it will be 45.33 kilonewton. So like that. And then we go to RA. We know that summation of upward forces is equal to summation of downward forces. So this one, it means RA is equal to 100 minus 45.33. So this one is equal to, you will also do it at your own with your calculator. 54.67 kilonewton. And then we will move to this section. So summation of moment at RB2 is equal to 0. So we'll have RC1 going in anti-clockwise, so minus 5. RC1, we come to 101, is going in anti-clockwise direction, minus 101.36. And then we come to UDL, in which direction? Clockwise, plus 45 times 5 times 5 over 2. So times 5, we are changing to the point load. Times 5 over 2, we are getting its moments. The moment of a UDL, it acts at the center. So it's 5 over 2. Then you come to 39, in which direction? 39 is clockwise direction. So plus 39.5 is equal to 0, which imply RC1 is equal to 100.13 kilonewton. And then after doing so, we'll find RB2. So summation of upward forces is equal to summation of downward forces. So RB2 is equal to 45 times 5 minus 100.13. So this one will give you 124.87 kilonewton. And then we proceed to the last section, which is this one. So summation of moment at RC2 is equal to 0. So we will have RB moving in anti-clockwise direction, and the distance is 4. So minus 4 RB minus 39.5 plus this 40 times its distance plus 40 times 1.5, like that. And then we have 45. We'll have minus, no, plus 45, minus 45. And then you come to this 30 plus 30 times distance from here to here, 5.5, is equal to 0. So y plus 45 minus 45, because if you consider 45 in this direction is positive, because that is clockwise. And then the other one again is anti-clockwise, so it will cancel itself. So it's equal to 0, which imply RD is equal to 46.38. 46.38 kilonewton. 46.38 kilonewton. Then we'll proceed to RC2. So RC2 is equal to 40 plus 30 minus 46.38. Reason, summation of upward forces is equal to summation of downward forces. So RC2 will give us RC2 will give us 23.63 23.63.63, like that. Now we have our all reactions. Now we have our all reaction. Now you can draw our shear force diagram. So our RA was 54.67 kilonewton. RB1 plus RB2. So this one is equal to 45.33 plus 124.87 is equal to 170.2. And then RC is equal to RC1 plus RC2. So this one is 100.13 plus 23.63. So this one is equal to 123.76 kilonewton. Then RD is equal to 46.38 kilonewton, like that. Now you can draw our shear force diagram. So this is our baseline. So shear force diagram. Saves my pen, so I'm not writing. Shear force diagram. So we will start by RA. RA is 54, so we will approximate 54. So around there, so this is 54, 54.67, 54.67. Then we'll take 54.67, 54.67 minus this downward force, which is 100 kilonewton. It will give you 45.33. So 45.33, 5.33, somewhere like there. Then we will maintain constant up to the next force, like that. So remember, this is 45.33. So negative 45.33 plus RB. This RB is this one. So plus 170.2. It gives you 124.87. So 124.87. So that is positive. So take 124.87 minus a UDL, which is 45, converted to a point load, 45 times 5. So it will give you 100, negative 100.13. So negative 100, somewhere like there. So 100.13. This are diagonal like that. And then you add RC, this one, plus 23.76. It gives you 23.68. So somewhere like there, 23.63. It will be constant up to loading 40. So minus 40. That one is negative 16.37. So negative 16.37. It will maintain constant up to RD plus RD plus this one plus 46.38. It will give you 30.01. So we will round off to 30. So this is 30. It will be constant up to the next loading, like that. So minus 30, it gives you 0. So you go back to 0. This is 0. So this is plus, minus, plus, minus, plus, minus, plus. So that is our shear force diagram. After doing so, we'll proceed and calculate our bending moment values, and we draw our bending moment diagram. So bending moment values. Before we calculate our bending moment values, we'll have to identify this point where the shear force is changing sign, and call it y. So the shear force is changing sign from positive to negative. So, and we will say, or we'll call that distance as x. So let's call this distance x. So this one will be 5 minus x. So it is very important to calculate this distance x, because it will help us in calculating our values for bending moments. So we'll use the similar triangle rule, and we'll say that 5 minus x over 124.87 is equal to x over 100.13. So if you use a similar triangle rules, you'll compare the sides of these triangles. So this is from here to here, this is from here to here. So 5 minus x over the height, 124.87. Then you come to this one. Here to here is x, this one. And then here to here is 100.13, which imply x is equal to 2.23 meters. So you'll find your x by yourself as you revise. So that is 2.23 meter. So the other distance is 2.77. So this one is 2.77. 2.77. And this one 2.23. Let me use another pen. So 2.23. like that. So we'll start calculating our values. So we know that bending moment at A, this was our point A, at A, this we calculated from our three equations, and it was negative 84.02 kilo Newton meter. So bending moment at F is equal to bending moment at A, which is negative 84.02 plus the area of this 4.67 times 3. So this one will give you 79.84 kilonewton meter. And then the bending moment at B will be bending moment at F, which is 79.84 minus the area of this. So that is 45.33 times 4. So this one will give you negative 101.48 kilonewton meter. And then bending moment at Y will be bending moment at B, which is negative 101.48. Then plus a half the area of this times 124.87 times 2.77. Like that. So this one will give you 71.46 kilonewton meter. Bending moment at C is equal to 71.46 minus the area of this. This is 0.5 times 100.13 times 2.23. So this one is equal to negative 41.3 kilonewton meter. So bending moment at G, at this point. So it will be bending moment at C, which is negative 41.3 plus the area of this. So that one is 23.63 times 1.5. 1.5 is from here to here. So the answer will be negative 5.85 kilonewton meter. Then bend moment at D will be bending moment at G, which is negative 5.85 minus 16.37 times 2.5. So this one will give you negative 6.78 kilonewton meter. So bending moment at E is equal to 0 kilonewton meter. So after doing so, now we can draw our bending moment diagram. So let's draw a bending moment diagram. So BMD, like that. So at point A, we have 84.02. So 84. So let's say it's there. So 84.02. Then we come to 79. 79 is at F. 79.84. And then you come to negative 1 at B. Negative 1. Okay, let's now draw our bending moment diagram. At point A, we have 84. Let's approximate 84.02. And then we have 79. 79.84. Then we have 101. 101.48. And then we have 71 at Y. At Y we have 71.46. Yes, and then we have at C 41.3. At C. 41.3. And then at the G, you have negative 5.85. 5.85. Then you have the last one, negative 46.8. Like that. So this one will be a diagonal line like that. Also this one. This one is a curve. Also, this one is a curve. This one is a diagonal. Also, this one and this one. So this one is negative, positive, negative, positive, negative, negative. Like that. So our question ends there. So having done so, we have calculated what the question required. So the question ends there.